The exam was moved 1 week. I don't know if I put this up yet. I'll make a note and make sure I did after class. But since there's no class on April 7th, I just moved the exam to the following Friday. And then your final is May 8th at 8 a.m. Any questions? Was there any questions on Monday or Wednesday's attendance? No. I had a few students with questions on this one. Simply, I think it was the wording, but remember the slope of the tangent line is just the derivative. And it's an equation because we don't have a number that we're putting into it. So that equation will work for any point on the line. And then when you want the actual slope, you put that X value of that point in. What we did here. So this is just the derivative. Any questions? Okay. Fridays we'll cover today. It's a product rule, which we'll learn that today. But any questions on Monday or Wednesday? If you do have any questions, just let me know. This one, the derivative is your slope. And then use y minus y1 equals m times x minus x1 and your points here. There's a few more problems I want to cover in section 7.1, and then we'll start 7.2. I've been trying to do more problems to make sure you understand everything since we do have a little extra time. And just practice a little more. 52. We did 51 last class right at the end, and we found the revenue equation. And 52 uses it. Suppose that for the situation in exercise 51, the cost of producing Q units is given by C of Q equals 3,000 minus 20Q plus 0.03 Q squared. Find the marginal profit for the following production levels. We know marginal is derivative, but we want marginal profit, which means we need to find the profit function. Remember from the last exam, profit is revenue minus cost. And so we use the revenue that we found in the equation before and then subtract the cost equation that they gave us. So revenue minus cost. Yeah. Now, what you have to remember, the way I have written is wrong. Because you want to subtract all of the costs. So you need to put parentheses and distribute that negative. But the most common mistake is to write it the way I had it So be careful. What you could do if you don't want to rewrite it, you make this a positive and then you change your signs. Mining like terms, q squared and the q squared, they're both negative, negative 0.04 q squared. 50q and 20 is 70 minus the 3,000. Any questions on that part? So this is the profit function. We want marginal profit. Marginal profit means derivative. Just about everything. If you're not sure what it is, take the derivative. That's going to be part of it. So if we take the derivative of this, 2 times the decimals a negative 0.08, u to the first because we subtracted 1. When there's no number, there's a 1 on this one. 1 times 70 is 70, and that's a plus sign. U to the 0 drops off, and the constant goes to 0. So that's the marginal profit. I wanted to double check. Q is units. So like sometimes it'll be hundreds of units and then you'd only put in a 5, but it's just units. So you'd plug the whole 500 in. And we're plugging in for Q because Q is the units and Y would be profit. It also is just in dollars. If it was anything other than dollars, they would state. If we are producing and selling 500 units, we will make a profit of $30 each. So marginal profit is telling you if you go with this amount, well, I guess it's actually telling you how it's changing. So the 501st unit. So it's telling you then, oops, 501st, but I put 51. It's telling you the next unit, how much it's increasing by. So it's telling you at that exact instantaneous change, at that exact point, how it's changing. And so that's why derivative is also instantaneous rate of change. Whereas when we found the average rate of change, you were finding how it was changing just between 2 points. This is telling you at this value, if you want one more, it would increase by 30. Let's see how it changes when we do B. 815. Notice at 815, the next one, the 816th one, profits still increasing, but only by $4.80. So it tells you whether it's increasing or decreasing if you go one more, and by how much. And 1,000. Notice the 1,001st item, we're actually losing. Now, part of the reason could be you're producing too many and there's not a demand on it. So it also depends on your demand, and that's why this must be a pretty good one. We're here, we're still making a profit, but not what we were making. This one we're actually losing, so you don't want to go that large. You're still making a profit, but it's going to be less. So this is telling you how it's changing. The 1,001st unit. So it decreases or lowers the profit. Any questions on that? Oh, I hit it twice. Okay, I want to do 53 because of the fraction. If the price in dollars of a stereo system is given by P of Q equals 1,000 over Q squared plus 1,000, where Q represents the demand for the product, find the marginal revenue when the demand is 10. All right, marginal revenue. Marginal revenue means the derivative of the revenue, but we don't have the revenue yet. We only have the price. Remember at the end of last class when we found revenue, it was price times Q. They gave us price right here. That's our price times Q. Revenue was in dollars, since price is in dollars. And Q was the demand for the stereo. Before I take my derivative, because this would need a product rule, which we haven't learned yet, I'm going to distribute the Q. I'm going to 1,000 times Q is 1,000 Q over Q squared, but this will reduce plus 1,000 Q. Now, when you're reducing, it's the top minus the bottom. 1 minus 2 is a -1. Now, I could have just canceled and left a Q in the bottom, but I know I need to take my derivative, so I would have had to brought it up anyways. So when you're dividing a top minus bottom on the exponents. Any questions on that part? So that's your revenue function. To find marginal revenue, take the derivative. So go ahead and take the derivative. Negative times the thousands and -1,000. And then when we subtract 1, we get a -2. This one, Q is 1. 1 times 1,000 is 1,000. Q to the 0 drops off. Any questions? No, they wanted marginal revenue at 10. So then we just plug in 10. Everyone getting 990? So when 10 are produced and sold, the 11th one will bring us $990. It will increase revenue by $990. Any questions on that? Let's try one more. Number 58. The total amount of money in circulation for the years from 1955 to 2014 can be closely approximated by M of T equals 0.006. Making it way too big. T squared. Okay. T represents the number of years since 1955. M of T in billions of dollars. M of T is the amount of money in circulation in billions. Let me take the derivative first. Find the derivative of M of T and use it to find the rate of change in money in circulation in the following years. So what you're seeing is we're going to 1960. How did it change? How much did it go up or down in 1961 and so on? So first thing we need to do is find the derivative because that's our instantaneous change. 3 times the decimal. And then 2 times the next decimal. T to the first plus 1.480. Is that what everyone got for the derivative? Any questions on it so far? Okay, now on Desmos or if you have TI-84 calculator, when you have a lot to plug in, you can use the calculator to make a table. Let me show you it on Desmos. Yeah. So to put this into a table, since we have several to plug in, you can click on the plus sign and go to table. But instead of X1 and Y1 over here, we want this equation, but you're going to use X1 instead of T, X1. The reason we're using X1 is that's what's over here. I tried changing it to just an X or T. It doesn't like that. So just leave the X1 and then put your equation here. So it would be 2. Now to get the squared. Oh, you need X1 and then the squared. Minus 0.15674. X1 plus any questions on that part? Make this a little shorter. So I just typed, whoops, the equation And this is nice when you have I mean, it seems like it's hard plugging it all in, but when you have a bunch you're plugging in, it's easier. Now we're not going to put 1960 in because T is the number of years since 1955. So that's 5 years. So we plug in 5. So it's the number of years since 1955. 5 years gives you 1960. So you plug 5 in. And there's your value. That means 1.21635. Remember, our answer was billions of dollars for M. What that's saying is 1961, there was an increase in the circulation by $1.2 billion. So it's telling you that in 1961, it still was increasing, and it increased by $1.2 billion. Oops. Oh, no, what happened here? Oh, there we go. 1980. So for 1980, we'd have to take and subtract. So we want to plug a 25 in. Now it's going to keep going by certain values, but not necessarily what we want. So the 26th year, or in 1981, it went up, because it's positive, by $10.5 billion. C, they wanted 2,000. So we want to plug in 40. Oh, it did get it right, 45. Which means in 2001, we increased our circulation by $36.5 billion. In 2010, which would be 55. Any questions on that? So when you do have a bunch that you're plugging in and you need to compare them, it's nice to use a table, and Desmos works really well. You can see each year, or well, these are multiple years, it's still increasing. And each year it's increasing by more than the years before. What do your answers in part A through D tell you about the amount of money in circulation in those years? So this is saying, so what was it, 1960? In 1961, it went up by $1.2 billion. This one was 1980. So in 1981, it was still increased by $10.5 billion. By 2001, we're increasing even more, $36.5 billion. If the equation is still correct. It says it goes to 2014. So they've only tested between 1955 and 2014. But any questions on it? So you didn't have to use the table. You could have just plugged it in with your calculator. But it does go a little quicker. Any questions? Okay, section 7.2. You're still taking the derivative, but there's two different rules. One is the product rule. And product rule is when you have two things multiplied together. So if your function is u times v of x, then the derivative is the first times the derivative of the second plus the second times the derivative of the first. Now, rather than try and remember u times v prime plus v times u prime, you can go f of x is the first times the second. So then the derivative is first times the derivative of the second plus the second times the derivative of the first. Oops, that's the one. Here we go. Okay, let's try one. So number one, and this is similar to your homework problem. This is the first, and this is the second. Yes, you could FOIL it and then take the derivative, but there are times where you wouldn't be able to do that, or it would make it more complicated. So if we take the derivative, first times the derivative of the second plus the second times the derivative of the first. Write down the first, 3x squared plus 2. And then we take the derivative of the second. What's the derivative of 2x minus 1? Anyone?
2.
Mm-hmm. Plus the second, 2x minus 1 times the derivative of the first. And the derivative of the first, 6x.
Yeah, that's what I got.
Now, on a test, you could leave it like that, and then if you have to plug in, just plug in. My math lab may want it reduced. It depends. Some problems, they allow you to leave it without reducing or simplifying, and other times they want you to simplify. But you would just distribute 6x squared plus 4, and then distribute this one. 12x squared minus 6x. And then combine like terms. 18x squared minus 6x plus 4. I would accept any one of those answers. I believe there's one on the test though where you have to do it this way and then you have to FOIL the problem and take the derivative and show that they're the same. It's on the take-home portion. Any questions on that one? So for Friday's homework, you can leave it in this form. I want to know that you understand the product rule. I know you know how to simplify. Any questions on that one? There is a power rule, but we don't get into it, or a chain rule. But we can rewrite it as a product because remember, squared means to take the binomial and to multiply it by itself. So then you have the first and the second. First times the derivative of the second plus the second times the derivative of the first. You are allowed a formula sheet, but the more you write it, the more comfortable you'll be with it. Go ahead and take the derivative. So 2x minus 5 times the derivative of the second is just 2. Plus the second times the derivative of the first, which is just 2. Any questions on that? Any questions on simplifying it? Okay, try number 7. Now remember that square root of x, we cannot take the derivative with it written like that. You need to rewrite it. So it becomes x to the 1/2. First, x plus 1. Derivative of the second, 1/2 times 1 is 1/2 x to the negative 1/2, and 2 is 0. Plus the second times the derivative of the first. What is the derivative of x plus 1? Anyone? Type it in the chat if you don't want to say. But what is the derivative of x plus 1? It's just 1. When there's no number, it's a 1. So 1 times 1 is 1. X of the 0 drops off. A constant goes to 0. It's just 1. And I would not go any further. Any questions on number 7? Okay, try number 9. Now, the nice thing is if you forget, do I take the derivative of the first one first or the second one first? It doesn't matter because you're adding them. Order doesn't matter. So this one could have been done first and then this one. It's the same thing. First, x to the -2 minus x to the -3. Derivative of the second. -1 times 3 is a -3x to the -2. -4 times 4 is a -16x to the -5. And I squeezed it. Should have kept it smaller. Plus the second times the derivative of the first, -2x to the -3 plus 3x to the -4. This would go in here. But is there any questions on that? Any questions on the product rule? And the next rule is the quotient rule. Quotient is a fraction. When you find the derivative, it's bottom times the derivative of the top minus the top times the derivative of the bottom all over the bottom squared. Of course, top and bottom, that's an easier way of remembering it. So when we take the derivative, it's the bottom times the derivative of the top minus the top times the derivative of the bottom all over I don't know why I wrote it all out, but bottom squared. Now, this one, it matters which one you do first because it's a minus sign. The derivative of the bottom gets the minus sign because remember, exponents in the bottom are negative. So that'll help you remember. The derivative of the bottom is the one subtracted. Let's try number 11. Bottom times the derivative of the top minus the top times the derivative of the bottom all over bottom squared. Bottom 3x plus 10. Derivative of the top 6 minus the top times the derivative of the bottom 3 all over 3x plus 10 squared. Any questions on that? On a test, you can stop there and plug in. You do not need to simplify it. There's a few cases where we want to set it equal to 0 where you'll have to simplify. But the bottom leaves squared. So if we simplify this, distributing the 6, we get 18x plus 60. Here, there's a -3. So I would distribute -3 at the same time, rather than distributing the negative and then distributing the 3, do them together. -3 times 6 is a -18x minus 3 all over 3x plus 10 squared. The 18x's cancel. 60 minus 3, 57. And there's your answer. And most of them, the top will simplify nice. Any questions on that? Okay, that is everything in this section. There's story problems and stuff, and we'll do more on Monday. So we did not do all of the story problems in 7.2. On my math lab, if you don't finish 7.2, it's no big deal. You'll just do it next week. But be careful. Some students are getting behind on other sections. You do have till the end of the semester. But you're going to have a lot of other work, so try not to get too far behind. But is there any questions? Okay. There are no questions. Have a nice weekend.
Thank you, you too.